Okay, let's see if this is actually gonna work. Is there anything else we need? Oh wait, we're just gonna, and action. Oh shoot, wait, it showed up on
Oh wait,
action.
how do I start? Like, hello, this is our image processing file project. We are team GRIJ, LC5004. It's me, Gabriel, Jason, India, and Reagan.
So how our team learned about image processing and engineering, we did some research on the different ways that it's like used in different fields of engineering. One of the ways we found was in manufacturing, and how image processing is being used to make assembly lines more autonomous by using error identification, which is where a item that has been constructed through either by like a robot or a person can be taken a picture can be taken of it, and it can be compared to a prefabricated object to like check for errors. And it can also be used in agriculture to study irrigation and flood management by analyzing pictures of geographical features.
Okay, so now we're gonna move on to a demonstration of the code. This is the code here. Start by clicking the run button, and it asks for a file. This example is going to use, oh wait, I should probably do this. I'm going to, this is the directory that the code is saved in. I'm just gonna empty it out of any of previous attempts so we can see this happen live. So as you can see right now, this is empty of any processed photos. It only has the original image that we're going to be processing. We're going to be doing the coins one. I'm just going to copy this. So as you can see, this is empty, and we are going to go to here, enter the image name of the file as png coins png.png. That was to test to see some of the naming stuff, but it's all working. So now it asks for if you want to do it automatically or options. I'll do the first demonstration automatically, just to show how that works. Automatic. And then it will take a few moments. And as you can see, once it's done, if we return to this folder with the original image and the code, you can see we now have output images of a lot of the steps along the way. So we have the original one. It's black and white and blurred. This is just black and white and blurred. They're a little out of order. This is kind of the end result with the thresholding. This image specifically, because it has a lot of background stuff, it's hard to get the thresholding exactly. So this is just an estimate, but maybe we can go back in the specific options and see if we can do a better job with this. This is with some edge thinning on the actual derivative. This is the x derivative. This is the x and y derivative combined, and this is just the y derivative. So those are the outputs of the files if you do it automatically. Now we can do another example. We should show some error catching. So if I type in, oh no, I forgot that it was called png coins, png.png. So I actually only wrote coins, but it says file not found. Please try again. So I'm going to actually enter the actual name of the file. Oh, I forgot the other PNG again. And there we go. So now this time I'll do options. I'll take a few moments. And it will ask me if I'd like to individually save each step along the way. Because I have this from last time, I'll say no. I'll do an averaging blur just because it's a little faster than doing the Gaussian blur. And I'll do a window of 3. And because that's actually the same thing that does automatically, I'll just say no because I already have a version of that. Then again, x and y derivative are going to be the same, so I just won't save those. And then again, I don't really need to save that because I already have this. And then this is an optional thing that is applied by default, which is the non-maximum suppression. How about to change it up? We actually will not run it this time, just to show something different. So no, but we'll use the double thresholding. I found it usually gives you a little bit better result. So I'll go a little bit with the default values. I think, just look at this image. We want a little more continuation on edges. So we'll do the same upper threshold, but a lower threshold because we wanted a little more. It gives you a little more continuation on edges that exist. And we'll see how that goes. All right, and let's see. What is it? Here we go. This is, as you can see, a little thicker because we did not thin the edges before the end, but we got a little bit, oh no, whoops. Got a little bit more of this edge up here, continued off there, but it's a little rougher around the edges. That's why I like to do the thinning, and that's why that's enabled by default. But you get a little more of this dome in here, a little bit of the head, and even a little words up here. So that's just a few demonstrations. We have to do 2 or 3 demonstrations.
It just said multiple, so that's probably good.
Okay, and that's a demonstration of the code and what it can get done. Thank you for watching the video. Is there anything else we need?
I don't think so.
All right, sounds good.